Okay, so here is parallel circuit worksheet two. Going to get into some more of these items here. So let's go ahead and we'll take a look at number one. You'll notice with these that we have a lot more um, branches that we're dealing with, and don't let that make you too nervous. We'll walk you through them. So let me just move this around here so we get the page straightened out for everyone to see. All right, so again, what I like to do is start out by labeling what they give me. So I'll put over here 12 volts. We got that one set up. We got some resistors that are involved here at 4 ohms, R1 and R2. R3 is 12 ohms, and R4 is 12 ohms. And in this case, we don't know the current that's going through this circuit. So you might already be thinking from our previous lessons, what do I got to solve for? And if you said resistance total, you are absolutely right. So what we're going to do is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And then I'm going to go ahead and start plugging in what I know in this case. So we've got 1 over 4, 1 over 4. R3 was 12, so 1 over 12. And then again over here, 1 over 12. And then we got to find a common denominator. So 4 and 12 will both go into 12. So we'll do that. Goes in 3 times, right? So these two become 3/12, and then 1/12, like so. 12 goes into 12 once. Then we can kind of organize these together. So you end up with 3 plus 3 is 6, plus 1 is 7, plus 1 is 8 twelfths in this case. Might want to reduce that down to 2/3, like so. And then, of course, we can do the inverse of this, right? So it'll become resistance total is equal to 3 over 2, or resistance total is equal to, what is that? 1.5, I believe, right? 1 and 1/2. Yeah, 1.5. Our resistance total is 1.5. Um, Now, once we've done that, we have to still solve for the current now that we know what the resistance total is. So again, we would go current is equal to, this would be our total current, right? Over our voltage divided by resistance total. So simple enough, right? Our voltage was 12 divided by 1.5 in this case. So IT is equal to, uh, should be 8, right? Um, yeah, 8. So 8 amps. Okay. So now I can go in here if I want, put in here 8 amps, like so. And then, so we got our amperage going in here. So, okay, coming out, coming in. Now, I'm going to divide this up just a little bit so we got some room to look at things here. So again, we've got these branches here, right? Which maybe we can label these B1, B2, B3, and then B4 over here, right? Oh, geez, that's terrible 4. Okay, so if we want to fill out these, we know that each one's got 12 volts at it, and we really only have to solve for R1 and R3 because those will be the same for their companions R2 and R4. So current is equal to voltage divided by resistance. Okay, for R1, let's do this one. So IR1 is equal to 12 divided by 4. or IR1 is equal to 3 amps, right? So if I wanted to label this now, coming out of here would be 3 amps, right? And then coming out of the back end here, 3 amps. And then again, this one's the same resistance value, so we don't even have to figure that one out. We already know it's going to be the same. So that's 3 amps and 3 amps. We will have to figure out branch 3, so let's go ahead and do that. So, sorry, I didn't change my color, but I don't think it's going to make a difference what we're doing. But 12 divided by 4. I'm sorry, R3 was 12, my bad. So 12 over 12. So IR3 is equal to 1 amp. So we go over here, coming out 1 amp. Same thing, right? And if you add those together, those different branches, 3 plus 1 plus 1 is 8 amps, and that's exactly what we've got flowing in that circuit total. So we know that this circuit is complete, right? We've solved everything here. So let me go ahead and let's take a look at question number 2. All right, so let's take a look at question 2 here. Get it on our screen. So for question 2 here, again, I'm going to label what I know in this case. So this one, I know the current, so coming out and then going this way will give us, sorry, I'm adjusting some things here so you can see it better. So we got current coming out. We got, what, 4 amps it says, right? 4 amps here. And then we'll go ahead and label our resistors. So we got 12 ohms, 12 ohms, 12 ohms. Oh, this is one of those easy ones, right? So if we know if we have the same resistance, right? We can divide it by the number of branches. So 4 divided by, I'm sorry, 12 ohms divided by 4 is going to give us a total resistance of 3 ohms. But again, I like to do it mathematically so you understand how they get there. So let's go ahead and write that out. And if you already know this, again, you can just skip over it, but I try to go over it for the practice for everyone. So there's our formula for resistance total. And this will be 12, 12, 12, and 12, which is going to be 4 twelves, and then that's going to be, I'm going to reduce this to 1/3. Then we can flip this over, right? The inverse will end up being 3 ohms. So that's what our resistance total is. So now, right, I'm going to block this off. We need to figure out, we're trying to solve for voltage still. So voltage would be equal to current total, right, times resistance total. So in this case, we've got total current of 4, and then we have 3 for resistance total, which makes our voltage value 12 volts. Okay, so that kind of solves one part of this, probably the only part the question is really asking us. Plus minus. And then again, if we wanted to figure out the different branches, they're all the same here. So we really just have to figure out one, right? Current would be equal to voltage divided by resistance. So in this case, each of the branches being fed 12 volts, and it's going to be divided by 12 ohms, right? So current is, in this case, through branch 1 amp. And so they're all the same here, so we can kind of figure that out. 1 amp coming down this branch, 1 amp, and down this branch, 1 amp, and then again coming back. And then you can add these all together, right? And the sum of these branch amperages should equal the total amperage that's flowing through the circuit. Okay. And it does. So this equation is all done. Fairly easy. It looks messier than it is. So let's go ahead and take a look at number three. All right, so here is number three. Again, we're solving for voltage. So it's going to be somewhat similar to what we've already done, but let's take a look. We'll go ahead and label. We don't have the voltage. So amp says flowing through this guy, right? 1 amp, fair enough. And then we've got, looks like 2 ohms, 4 ohms, 6 ohms, and 12 ohms, just like this. And if you're saying, hey, you've got sulfur resistance total, you're catching on, right? That's exactly what we're trying to do. So that's the very first thing we're going to figure out. So write out our formula. We got 4 branches, 4 different loads. And so this would be 1/2, and then 1/4, 1/6, and 1/12. And then we need a common denominator. So these will all, 2, 4, 6, and 12 will all go into 12, right? So if we put 12 here, 2 goes in 6 times. Then 12 here, 4 goes in 3 times. And then 12 here, and 6 goes in 2 times. And then, of course, 12 only goes into 12 once. So we can add this together. And we end up with 6 plus 3 is 9. Plus 2 is 11, and 1 is 12. So 12/12. Do the reciprocal, and we'll come up with RT is equal to 1 ohm. So now that we know the resistance total, we can then now go ahead and solve for voltage. And voltage in this case will be equal to the total current times the total resistance. And so we have 1 amp times 1 ohm. So our voltage in this case appears to be what? 1 volt. Okay. I'm going to go ahead and put that in here. And this is where you got to trust, the process and the procedure, because you might have thought, well, everything was 12 volts before. So now they're changing up some variables. Let's make sure that our math, it makes sense. Let's start trying to see if we can solve for our um, amperages through each one of these branches, right? So I'm going to go IR1 is equal to voltage over resistance. And if I do that over here, that would be 1 divided by 2, right? And then if we, in some of these cases too, it's advisable probably to have a calculator to solve it. If we divide 1 by 2, we end up with 0.5 amps. So let's do that for the next one. IR2 is going to be 1 divided by 4, right? And in that case, you're going to get um, 0.25 of an amp. And then we got IR3. And IR3 again is going to be 1 volt divided by 6. And you'll end up with some long numbers here. Obviously, the more numbers we keep in this case, the better. I'm just going to go 3 deep with it, rounding it off. And then IR4 right here is going to be 1/12. And 1 divided by 12 is 0.083 in this case, right? And again, I'm just rounding off. Now, if I add those together, 0.5 plus 0.25 and 0.167 plus 0.083, I end up with 1, right? That's all of these if I add them together, right? It comes out to 1 amp. And that matches what we've got flowing in this. So I would say we've done a pretty good job right there. Everything matches up. And so this is good. All right, let's take a look at number 4. All right, so for question 4, we are now going to be finding the current for this one. So let's go ahead and line up what we can. We got 12 volts here. We don't know the current. It's okay. And then R1 is 8 ohms, R2 is 8 ohms, and R3 is 4 ohms. And once again, we're going to have to figure out our resistance total, this time only with 3 branches. So I'll plug those numbers in. And we'll have to find a common denominator. In this case, 8 is what we got. So the first two will stay the same because 4 and 8 will both go into 8. And then, so this is, so from here, now we can just add everything together. So we end up with 4 over 8, which is what, 1/2. And if we do the reciprocal of these, RT is equal to 2 ohms. Okay. All right, so I'm going to block this off. So now that we know the resistance total, right, now we solve for the current. And the current total in this case is going to be our applied voltage divided by our resistance total. So current in this case is equal to 12 divided by 2, or 6 amps. And so over here, we can write in 6 amps right here for our solution, which means that we've got going this way 6 amps and 6 amps. Um, so from here now, we can solve for the branches here. R1 and R2 are going to have the same current because they have the same resistance through them. So I'm just going to solve for the first one. So for 1 would be voltage divided by resistance. So IR1 is going to be 12 divided by 8. And that's going to be what? 1.5 amps. So we know coming through this guy, 1.5 amps, 1.5 amps, and then here, right? 1.5 amps, and then here, 1.5 amps. So the only one that we really need to solve for here is going to be for branch 3. That's the one that's got something different. So we're going to write in here, again, voltage divided by resistance. So IR3 is equal to 12 divided by 4, or IR3 is equal to 3 amps. And then so in here, we've got 3 amps, 3 amps. Now, if we add that together, all 3 branches, we got 1 plus 1.5 plus 1.5 plus 3 equals 6, and that's what we got in the circuit. So that is a sound solution. Let's look at number 5. All right, so let's take a look at number 5 here. And then this one, these are the ones that I mentioned before. I think myself are sometimes the trickiest because we got this resistor that we don't know what it is. So I'm going to list what I do know. I know I got 12 volts here, right? And then my current going through this to here is going to be 4 amps coming out of the circuit and 4 amps coming up this way. Our resistors in this case are going to be 12 ohms and then 12 ohms for R2, and R3 we don't know. So that's what we're going to be solving for. Okay. So to do that, make this a little better. To do that, we have got to figure out what our resistance total is, as you might recall. So to figure out resistance total in this case, I'm going to multiply or divide, I'm sorry, my voltage by my amperage, right? So RT is equal to voltage divided by current, right? And we can swap those numbers in. We've got 12 divided by 4, or resistance total of 3 ohms. Then I'm going to use my parallel circuit, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And then from here, we're going to go and plug the numbers in that we do know, right? So we got 12 and we got 12 again, and we don't know uh, R3. Oh, and I made a slight error here you might have picked up on. I do know RT now, right, was solved for 3. So this should look like that. Now, what I want to do is I'm going to flip things around here. I'm going to put 1 over R3 plus 1 over 12 plus 1 over 12 is equal to 1/3, like this. And then what I'm going to do, I'm going to try to combine these, because 1 over 12 plus 1 over 12 would be 2/12 is equal to 1/3. I'm going to carry this up here where we got a little more room right here. Let's rewrite this real fast. Okay, so now I can take this guy and subtract 2/12 from each side, right? Which is going to give me 1 over R3 is equal to 1/3 minus 2/12. And then I need a common denominator. So 3 goes into 12 4 times, and 12 goes into 12 once. So this stays the same. And then 1 over R3 is equal to 2/12. Or you could say this is actually 1/6. So R3 is equal to 6 ohms when we look at the reciprocal. So up here, I'm going to label this as 6 ohms here. It will plug in here, 6 ohms. And I'm going to erase some of this now so that we got some room to work to figure out our branches. Let me get rid of this for us. Okay. All right. So sorry about that. I had a little distraction. Um, so if I want to solve for the branch resistances or the branch currents now, right? The R1 and R2 will be the same. So current is equal to voltage divided by resistance. And if we did this for R1, for example, IR1 will be 12 divided by 12. IR1 is equal to 1 amp, which means that for this one, we got 1 amp. And for this one, we got 1 amp. So they got the same loads on them. So we don't need to do the math for both of those. Same resistance values. We will need to now solve for IR3. That one's different. So IR3 is equal to 12 divided by 6. So IR3 is equal to 2 amps. And so coming through here is 2 amps, and coming out the bottom here is 2 amps. And if we add 2 plus 1 plus 1, we got 4 amps. That's what we got flowing in this circuit. So that makes sense as well. All right, great. Let's take a look at number 6. All right, so for number 6 here, looks like we're going to be solving for voltage. So I'm going to label what I can as I've done in the past. So we've got 2 amps here and 2 amps here flowing in this thing. We then have resistance values of 24 ohms, 24 ohms, and then 12 ohms over here. So very first thing I want to do, I'm going to figure out my resistance total. Same formula, 3 branches. So 1 over R2 plus 1 over R3. And then, so 1 over RT is equal to 1 over 24, 1 over 24 plus 1 over 12. We're going to need a common denominator, and 12 will go into 24, so these will stay the same, right? This one will change to 24, which will make that 2. So now our total is 1, 2, 3, 4. So 4 over 24. 1, 6. So resistance total for this one is 6 ohms. Okay. So now once we know that, we can now just simply use Ohm's law. So we can say voltage is equal to current total times resistance total. So this is going to be 2 times 6. So our voltage is 12 volts. So now over here, we'll put in 12 volts, 12 volts for us here. And we have pretty much solved that equation. Only thing we can do, we get rid of some of this stuff. Let's take a look at the branches, right? Let's take a look at these branches and see what's going on. I like to do this because this acts as like a double check to make sure that my solution indeed is gonna work. So for this problem here, we are going to use that current is equal to voltage divided by resistance. Sorry, this should actually be R1, because that's once we solve for R1, we'll know our current through R2. So we got 12 divided by 24. So IR2, when we take a look at this, would be reduced to 1/2, or IR2 is equal to 0.5 amps, right? So coming out of here, 0.5 amps, 0.5 amps. So we've already got 0.5 and 0.5, which would give us 1 amp. We should be saying to ourselves, well, that makes 1 amp. We got 2, so this one R3 should be 1 amp. But let's make sure, right? So we'll go IR3 is equal to voltage over resistance. IR3 is 12 divided by 12. So IR3 is 1. So indeed it is 1 amp. So here coming out 1 amp, and then coming back 1 amp. So if you add 1 plus 0.5 plus 0.5, come up with 2 amps, and 2 amps is what we have solved for. Our there's what was given to us as the total current that was running through it. So that makes sense. All right, so I guess that wraps this one up. Next up, we'll do worksheet 3 on parallel circuits. Thanks for watching, guys. Bye.